Good evening, everyone. Today we're going to present our project on building a recommender system based on the Instacart market basket analysis dataset. Here are the team members and their respective responsibilities in this project. The project goal. Our primary goal is to create a robust, scalable, and efficient data infrastructure that can handle large volumes of diverse data, transform this data into actionable insights, and deliver real-time recommendations to our users. By doing so, we aim to improve user satisfaction and engagement. To address these challenges, we're building a comprehensive data lake solution using AWS services, integrated with machine learning capabilities, as well as advanced analytics and visualizations. Key components including data storage and processing, model training and development, and data serving. Our proposed data lake pipeline involves several key steps: data storage, processing transformation, machine learning, advanced analytics, and web page for a real-time prediction. Storage. To start off, our client will put their files in the raw bucket. This is the input to our data lake. Once the data is collected, we use a Lambda to copy and decompress those files to the staging bucket. Then separate glue jobs are used to first convert CSVs to Parquet and save to the transform bucket, and then process and save the training and testing data to the machine learning buckets for SageMaker to use. To provide real-time predictions, we use SageMaker for training and deploying machine learning models. When users send requests, they go through API Gateway, which activates a process in SageMaker to generate predictions. These predictions are then quickly returned to the users, providing a smooth and efficient experience. For in-depth analysis, we use Snowflake. Snowflake allows us to perform complex queries and analysis. We then use Tableau to turn these insights into easy-to-understand interactive dashboards for stakeholders. The pipeline is orchestrated using step function, which is triggered by event bridge. The period is set to 1 day. As shown here, a Lambda is first used to copy files from client to our data lake. Then two glue jobs are used to convert CSV file to Parquet and extract features from machine learning engineers. And in case of any error, or if the pipeline runs is successful, the message will be sent to a SNS topic, which is then sent to the subscribers. Here is a demonstration. The whole process takes about 10 minutes to run. Okay, let's start it. Okay, it's started. Cool. Okay. For CI/CD and resource provision, we use GitHub Action and code formation. We push code changes to GitHub repo, and a pull request or a push domain triggers a GitHub Action workflow. GitHub Action uploads scripts and templates to S3 bucket and then triggers CloudFormation to provision or update resources. We manually deploy Lambda and API Gateway using serverless architecture. Each user is created using Bottle 3, where some basic policies are given, like reading bills, restricting resource region to Sydney, and some limited IAM access, like viewing permissions, enable MFA, etc. Finally, the email with initial login credentials are sent using SES client, like that. Okay. Here are the contents of our presentation. Thanks.
Hello, everyone. This is Kai. And firstly, we talk about the storage. In this article, files are uploaded to a raw bucket, and AWS Lambda is triggered by the upload event. and Lambda decompress GS files, making the data usable. The reason for decompress, in the group job, we have configured 2 DPUs for code saving, and the decompression process for a single file may only utilize 1 visual CPU, while processing CSV files can leverage the multiple visual CPUs available, thus eliminating any potential bottleneck. And the processed files are then transferred to a staging bucket with a specific prefix. And this initial step ensures the raw data is organized and ready for further processing. And next. And next. Yeah, and then we have we do the Glue. The Glue catalog is a centralized metadata repository that stores stable definitions, job metadata, and other control information. It enables us to easily manage and query our data across various AWS services. So next, Glue job CSV to actually read the data from the staging bucket using AWS Glue catalog. And this job transforms the files from CSV format to PARQ format, which is more efficient for querying and analysis. And the transform files and then stored in the transform bucket. This step optimizes the data for subsequent ETL process. And finally, Glue job ETL reads the transform data using also the Glue catalog. And the code calculates various users and product features such as order history, reorder probabilities. These features are then merged into a comprehensive output data set and divided into training and test set. The processed data is now ready for SageMaker. And next.
Good evening. So for the ETL process, we have to implement several changes. Firstly, we optimized the query in Q2, the question 2. So we modified the query to only use the data where the eval set equal to prior to eliminate non-useful data, ensuring a more accurate input for machine learning. Secondly, we utilize Glue catalog to manage the schema, improving the centralized metadata management, data governance, and security. And thirdly, in the Glue job process, we use the cache and unpersist function to cache 2 data frames to improve the performance and reduce the computation time. Lastly, we encrypt the data that's stored in the S3 bucket to ensure the security and integrity of the information. Next, please.
Okay, come back to Kai. I'm talking about the security. We use KMS tools. In this project, 2 KMS keys were established for different teams, both used in conjunction with S3. The first key is for the data engineering team to use in their ETL process, ensuring the secure encryption and decryption of data stored in and retrieved from S3 during extraction, transformation, and loading. And the second key is for the machine learning team, enable them to securely handle and process training data stored in S3. Both keys are used for encryption and decryption data, compressing and decompressing files, and generating data keys for additional security layers. This approach ensures that each team's data remains secure and separate with control access and enhanced compliance. Yeah, next.
Hello, this is Tim. I will talk about our machine learning model training and deployment. Our business objective is that based on the previous order histories, we wish to predict whether a customer will buy a product in the next order. Our machine learning tool is the fully managed AWS SageMaker. We favor this service because it automatically scales based on machine learning workload. It allows easy model deployment as scalable low latency endpoints for real-time predictions or batch transformations. Our choice of algorithm is XGBoost because it uses gradient boosting, which improves model accuracy by combining the prediction of decision trees to produce a very strong model. Since our task requires true or false binary response, and XGBoost is widely proven and recognized for effectiveness in binary prediction tasks. Next, please. We start with feature engineering. The primary keys of the input variables are user ID and product ID, and the response variable is a binary variable reordered. And we work closely with data analysts and use the order product prior set, which contains customers' order histories, to first determine a few basic custom purchase features, product features, and customer product features. And based on these features, we build more features upon which aiming for letting our model to learn more features. And we can also add more feature or delete features based on the performance of our model in the future. Next, please. Next, we prepare our dataset for model training. So we first start a notebook instance in SageMaker, then connect to the group catalog through Boulder 3, and retrieve the table information for the dataset and download data from the corresponding S3 bucket to the notebook instance. We then audit the data, check the quality, then we split data into 80% train set and 20% validation set. Finally, we upload the train validation set back to the S3 bucket, and this concludes the data preparation for the model training. Next, please. Before we fit our XGBoost model, we need to choose the hyperparameter for the model. For example, we have chosen the objective function, which is binary logistic, which is the logistic regression for binary classification, which outputs probability. And we can also use hinge, which outputs 0 and 1 instead of probability. And also the maximum depth, which is the maximum depth of the tree. Increase this value may cause overfit. And the ETA, which is the step size shrinkage used in updates to prevent overfitting. And boosting become more conservative the bigger ETA is. And the gamma value, which is the minimum loss reduction required to make a further partition on leaf node of the tree. The larger the gamma is, the more conservative the algorithm is. And also there's a range of other parameters to choose from. After fitting the model, we can perform a hyperparameter tuning based on the fitting model with a tuning range for each parameter. By selecting the maximum number of models to train, the tuning will automatically select a best training model based on the tuning range. Next, please. We then deploy the model to an endpoint for real-time and batch predictions. We also use the training model to build a batch transformer so that we can determine the threshold for labeling true or false. By performing batch transformation on the training dataset and comparing the density distribution and probability of the true label and the false label. We can also perform batch transformation for the test dataset and label the reorder column based on the threshold selected, and compare the predicted response of a test set with future data, then evaluate the performance model, adjust and tune the hyperparameter model, and iterate the process. At this stage, we haven't done the transformer job because we need to apply for instance through the AWS quota to run the transformer job. And that concludes the overview of our model training and deployment. I'll hand over to Sam.
Okay. We use lake formation for fine-grained control on data available to data analysts. Here is a demonstration. So 2 accounts are used. The first account is Sam, who has admin access, whereas Sam second only has access to Athena, decrypt access to the particular KMS key for the bucket, and lake formation get data access. A data filter is used to demonstrate limited access to the first 5 rows of the table, and selected columns of a table. This will only be a demonstration as we don't have any sensitive data to filter out. Okay. So as shown here, I'm currently logged in as the main account. If you run the query, you can see the full structure of the table. Like 10 rows, and all the columns. Please pay attention to this aisle ID and department ID. So they should be filtered out later, and only the first 5 rows will be shown. Okay, let's log in again using my secondary account. Same query. Let's run again. Although we want to show first 10 rows, we can only show 5 rows because it's limited, and aisle ID and department ID has been filtered out. Okay, let's go back to the presentation.
I will share with you our experience in analyzing and visualizing transformed data using Snowflake. We tried 2 different methods. The first is using external table, and another is Iceberg tables. Next, please. First one is using external table. We tried was configuring Snowflake to directly access data storage in Amazon S3 via external tables. There are the 7 steps. The first is config access permission for the S3 buckets. It ensures the right permission are in place to access the S3 bucket. Then we will create a role in AWS. It establish identify and identity and access management role in AWS. The next is create a cloud storage integration in Snowflake. It will link Snowflake with S3 storage. Step 4 for getting the necessary user credential. And the step 5, the users to access to the object within the S3 bucket. Finally, we will create an external stage and copy the data from S3 into Snowflake for analysis. But however, this method requires the data schema to be per defined when creating table, and if any difference between the defined schema and the actual data in the S3 bucket can lead to issue during data copy. So to overcome this challenge, with the help of our tutor, we explore the second method using Iceberg table. Next, please. There are the 2 important steps. The first is configure an external VM for Amazon S3. It is similar to the first method, but was a slight policy difference. And the second is configure catalog integration for AWS Glue. It will grant Snowflake require access to the AWS Glue data catalog. By completing this step, we can create the Iceberg table with AWS Glue as a catalog. We directly read from the Glue catalog, ensuring only data that match the defined the schema is read. After configuring the data assets, we perform the analysis and successfully connect our result to Tableau for more visual representation. Next, please. For the purchase frequency and interview analysis, our analysis shows that most users purchase a specific product around 5 to 6 times, with an average interval of 7 days between purchase. Next, please. For the product popularity, by calculating the purchase frequency of each product, we identified that product ID 24852 is the most popular. And for the user performance, analyze user preference, assess different cataloger within that product is in the department ID 4 are the most performed by user. Next, please. And for the purchase habits, evaluating user purchase habits, we found that users are more likely to place order during weekends, with peak order time between 10 a.m. and 6 p.m. These insights have been effective visions in Tableau, making the results more accessibility and actionable. Yeah, hand to Tim and Amber.
We also provide real-time customer product buying prediction service for our front-end users, such as our analysts. To achieve this, we have used AWS API Gateway, which handles requests from users. And when a request comes in, API Gateway activates a process that generates a prediction using our trained model hosted in the SageMaker endpoint. Then the endpoint quickly processes the data and returns the prediction to the analyst through the API Gateway, allowing us to deliver recommendation instantly. Next, please. Because we want to speed up the development and deployment, we have used the serverless framework to deploy our real-time prediction service. And later, we'll migrate this the IAC to our main cloud formation workflow. And we have created two Lambda functions, which will be triggered by an API endpoint. So when the end user sends a user ID to our API, it will trigger the user product function, which will use the bottle 3 to connect to Athena, then query and return the unique products information that this user has bought. Then the front-end user will obtain the product information, including product ID, product name, L name, and department name of the product. Then the end user can send a pair of user ID and product ID to the API, which will trigger the second Lambda function, user product probability, which will query and return the features of this user ID and product ID. Then it will invoke our model endpoint and return a probability to the front end. So that's the overview of our real-time prediction service, and I'll hand over to Amber.
Hi, this is Amber, and I'm going to talk about how our project isn't just about handling data in real time. It's also about giving you the power to customize how you use the data. Take the front end you see here. For example, you can simply type in a user ID and instantly you will get all the purchasing information for that user, including their likelihood to buy again and details about the products they are interested in. And this may help their data analysis team at Instacart by delivering these precise product suggestions based on real-time insights. They just not only meeting needs, they also can pushing their sales figure higher. And that's all. Next, please.
And for the last part, we use Jira to manage our project tasks and meeting minutes. Okay, let's finalize our presentation with, oh, please send again. See, I don't have this permission. Let's resign using my main account. Okay, has the pipeline is successful, and we should be seeing an email sent to our email address like that. It says the step function has run successfully. And if we go, the duration is only about 10 minutes. If we go back, we can see this run was successfully triggered by, what is it called? EventBridge this morning. Okay. Cool, that's it. Thank you.